Hello, my name is Ian Gross. Today I'll be talking about my project, question answering using BERT. To go into the background a little bit, question answering in general is the task of automatically answering questions based on human text. There are several subtasks such as logical reasoning, natural language reasoning, text generation, and machine reading. It's either usually constrained to a single topic or multiple topics, and it's still widely actively researched in the NLP community and has a lot of data sets. The second main topic is semantic word representations. There's been a newly released model called BERT, bidirectional encoder representations from transformers, which was pre-trained on Wikipedia article by Google in 2018. It's able to learn sentence context as opposed to previous models, and it can handle tasks such as text classification and sentence pairs. So the problem statement I try to solve is I want to use the BERT model for predicting answers based on text. There have been previous implementations of this, such as the Squad dataset, and I plan to use this as a base for incorporating a new dataset with Google's natural language question dataset. I will be performing data pre-processing, and then I'll make modifications to the model based on the natural questions dataset, modifying hyperparameters to potentially improve results, and then analyzing the results. So in terms of my hardware environment, I use my personal computer, Windows 10, with a Core i7 to do development. And then I use a proprietary cluster to actually do the training. The processor is a NVIDIA Tesla P100 GPU. I would recommend using a GPU for this. This could be done on AWS or a cloud GPU instance. So to go through briefly the software, libraries, and environment, I'm using Anaconda 3.7 to manage everything. Python 3.6, various packages such as TensorFlow, NumPy, Matplotlib, and Spacey. And I use Conda virtual environments to manage this. GitHub has the code implementation of the original BERT model. And I use a text editor to modify the text, and Ubuntu subsystem for Windows for actually running things and SSHing into the cluster. The Squad dataset is what I base my original model off of. The Squad dataset is a reading comprehension dataset by Stanford. It consists of questions posed by crowd workers on a set of Wikipedia articles. The answer to every question is a segment of text or a span from the text article, and the newer version means that a question may be unanswerable. It's all in JSON. It's split up by title and paragraph, and it also has the start position of the answer, and if the answer is impossible. So to go through the data set that I use Google's natural questions data set. It was human-generated questions on Wikipedia. The purpose is to provide a realistic and challenging QA data set. It's broken up into 5 categories: short, long, impossible, yes, no. The data set is pretty large, so I would recommend downloading the sample data set. I personally downloaded the larger one. You have to use Google's package gsutil to do that. I only took the first portion of it, the 0.0 version, but just use the sample for testing. In terms of content, this data set has document annotations which indicate what the type is, and it also has a few other things like the HTML, the tags of the different tokenized text, the ID, and a few other different things. Here's just a quick description of the data, what it looks like. The annotations is what houses the answer information. And there's a few other different things in here that are of interest, but we don't need to go into too much detail on them. So to quickly go through the steps, you would install Anaconda and set up your virtual environment, then download the dataset, and then load the dataset using the pre-processing steps, using the script that I provide. Then I modified BERT and trained on the training set, and then repeat this for the prediction on the dev, and analyze the predictions and visualize the results. These are the values I used when training my model, and here's some run instructions below. So for data pre-processing, I only described some of the more complex tasks because there's a lot of things going on in the back end. But basically, I determined the answer type based on annotations, and then I removed HTML tags and adjusted the answer token accordingly. Then I modified the input function to accommodate for adding a new model feature from the answer type. The tokenization that's already done by BERT is lowercasing, removing non-UTF text and then splitting the text. It also does this combined input question text with these different tokens over here. Then it does subword tokenization where it creates a map to the original word and it splits it up by its meaning in the word itself. Here's an example where they split up John Johansson's and a sample mapping. And then they split the input into segments for processing and define each input token as part of the question or the article text. This is quickly just a brief overview of the model. This is for Squad. It's found in the paper itself. The basic premise is that it uses a stack of encoders, and I modified this model in the input section to include the ability to predict the answer type as well. So some results is I predicted the answer type, the text, the start and end position of each answer in the question, and then additionally the logits for the start and end and answer type. The top predicted results for each answer was calculated, and the probability of each top result being answerable. I also tested two different hyperparameters. I probably should have used ones that were more separated and a few other more, but we'll get into that later. I also found that both of those learning rates for some reason had the same precision recall. I had some issues calculating the score, but I did find it was able to identify all the unanswerable questions with 100% accuracy, but it had difficulty identifying the answerable questions. Going into the data itself, it had about 1,500 examples in dev. Here's the split of answerable to non-answerable questions. There's definitely an imbalance between the two, which may have had an effect on things. I found that longer answers were a lot longer than shorter answers, and the way I formatted with HTML tags, I removed them. That may have caused some sentence processing issues. In general, this data processing was somewhat complicated. I also found the model had difficulties identifying answers after about 200 tokens in the text. Here's some sample results. On the top left is some predictions, the ID and the predicted answer, the odds of it being answerable in the bottom left. And on the right, it shows an ID with a question, its correct answer, and the top predicted results. This is some of the result type analysis that I performed. The bottom right generally shows that a lot of the unknown questions were correctly identified. It was able to get a decent amount of small ones, but it had a lot of difficulties with the longer answers. This is for the top predicted results, by the way. I also found that changing the learning rate didn't really make too much of a difference, but it did kind of skew things in different directions in terms of what got more correct answers for short and long. So more testing probably needs to be done on this in the future. So some lessons learned. I found that BERT and its pre-processing steps are pretty complicated. At modifying the model is very difficult as well. Using prepackaged model for BERT, such as PyTorch or AllenNLP, would have probably made this a lot easier. And probably using a bit of a simpler data set with text already pre-processed, or some standard way to handle HTML text would probably be a preferred method. In terms of pros, I found it was pretty good experience learning how the state-of-the-art word embeddings model work, especially for this particular NLP task. I found it was a decent starting point for potentially continuing similar work in the future. And overall, in terms of cons, I found it was pretty difficult to actually implement the data set into the model and make modifications to the code. In terms of future work, I definitely want to test this on different hyperparameters. Only being able to do two was just a matter of time constraints. I do want to fix the code to eventually produce better results and see what was wrong with my evaluation functions. Then I want to review some of the pre-processing steps for natural questions and potentially improve the results, such as fixing the HTML pre-processing. I would also want to probably only limit this to a specific domain use case. And then also I would potentially want to incorporate this into a more complex use case, depending on the domain. And that is it. Thank you.